Okay, so imagine looking deep into space, about 64 light-years away. You spot this gorgeous, deep blue marble of a planet. It looks familiar. Almost peaceful, right? But if you could actually go there, you discover that exoplanet HD 189733b is one of the most violent, absolutely terrifying places we have ever found. So let's pull back the curtain on this beautiful nightmare.
And yeah, this really sums it up perfectly. The appearance? A calm, serene blue world. The reality? A place where it rains molten glass sideways at over 5,000 miles per hour. This is the insane paradox we're going to unpack today.
You know, that's not some dramatic line from a sci-fi movie. That is how actual scientists describe what it would feel like to be caught in this planet's atmosphere. So the big question is, how on Earth did a world that looks so beautiful end up being so unbelievably hostile? All right, so our story starts out in the constellation Vulpecula. This is HD 189733b, and it belongs to a class of exoplanets that just totally shattered our old ideas about how solar systems are supposed to work.
See, it's what astronomers call a hot Jupiter. So picture a planet a little bigger than our own Jupiter, but instead of hanging out way out in the cold, dark edges of its solar system, it's practically scraping the surface of its parent star, getting absolutely blasted with heat and radiation day in and day out.
And when I say close, I mean really close. Its orbit is about 20 times tighter than Mercury's is to our Sun. It just whips around its star in only 2.2 days. Can you believe that? A whole year takes less than 3 days. And this extreme closeness, well, it's the key to everything that makes this planet so incredibly wild.
Because it's so incredibly close, the planet is tidally locked. You know how we only ever get to see one side of our moon? It's the same deal here. This planet permanently shows one face to its star, which creates a permanent scorching hot day side and a permanent dark night side. A world of two extremes.
And check this out. The day side is a blistering 1700 degrees Fahrenheit. I mean, that's hot enough to melt lead. But because of some crazy weather, the night side, while still insanely hot, is a few hundred degrees cooler. And this massive difference in temperature, that's the engine that unleashes the planet's absolutely insane weather.
That temperature difference drives winds that are it's hard to even comprehend. We are talking 5,400 miles per hour. That is one of the fastest wind speeds ever directly measured on an exoplanet, and we clocked it all the way from Earth. To give you an idea of just how fast that is, that's Mach 7. We're talking about supersonic winds that are constantly roaring from the hot side to the cool side in a perpetual planet-circling storm. But here's the thing. These winds aren't just carrying air. So, back to the big question. If this planet is such a hellscape, why does it look so beautifully blue? For a long time, this was a huge puzzle. I mean, we can't just take a picture of these planets directly, so scientists had to get really creative with the Hubble Space Telescope to solve this one.
And it was actually super clever how they figured it out. They watched as the planet went behind its star. Naturally, the total light from the system dropped a bit. But here's the genius part. They noticed the light dipped way more in the blue part of the spectrum. That was the smoking gun. It proved the planet itself must be reflecting blue light back at us.
So what's causing it? Well, it all comes down to something called Rayleigh scattering. It's the exact same reason our sky on Earth is blue. But, and this is a huge but, it's not been caused by molecules like nitrogen or oxygen. The blue color comes from a high-altitude haze made of tiny silicate particles. In other words, the beautiful blue comes from an atmosphere laced with the building blocks of rock and glass.
And this is where it all comes together. We're going to connect that blue-making haze to the planet's horrifying weather forecast. Because those little silicate particles, they aren't just floating there looking pretty. No, they are at the very heart of the storm.
And I want to be perfectly clear, this is not a metaphor. The weather on HD 189733b is quite literally sideways glass rain. Let's walk through how that's even possible.
So here's how it works. On that scorching day side, the heat is so intense it literally vaporizes rock into a silicate gas. Then, those supersonic 5,400 mile per hour winds grab that vapor and just whip it around the planet. When the vapor hits the slightly cooler parts of the atmosphere, it condenses back into solid form as tiny grains of glass. And then, those glass particles get blasted sideways in a permanent planet-wide storm of flying glass shrapnel.
And this isn't just a cool theory. Just this year, the James Webb Space Telescope gave us our best look yet. It directly detected clouds made of tiny quartz grains, a specific type of silicate.
It also sniffed out hydrogen sulfide, the gas that smells like rotten eggs, which is giving us brand new clues about how this bizarre world even formed in the first place.
So you might be wondering, why are we so obsessed with this one single bizarre planet? Well, it's because its extreme nature makes it the absolute perfect cosmic laboratory for testing everything we think we know about planets beyond our solar system. I mean, just look at this incredible journey of discovery. For nearly 2 decades, each new generation of telescopes has peeled back another layer of the mystery. First, Spitzer gave us the first ever heat map of an exoplanet. Then Hubble confirmed its color. HARPS actually measured the wind speed. And now, JWST is telling us what the clouds are actually made of.
Ultimately, HD 189733b is the benchmark. It's the world we compare other extreme planets to. It pushes all our models of atmospheric physics right to the breaking point. And if all that wasn't enough, get this. Its own star is blasting its atmosphere away into space, stripping off over 1,000 tons of material every single second.
We've learned so much from this one, single, beautiful, terrifying world. It's just such a powerful reminder that the universe is filled with places more extreme and more fantastic than we could have ever dreamed up. It really makes you wonder, doesn't it? If this is what we can find just 64 light-years away, as our telescopes get even more powerful, what other wonders are waiting for us just out of sight?